So up until this point, our U substitutions have worked out pretty nicely. Sometimes we've had to do a little bit of extra work, but essentially, like any time we had an extra x, things worked out and we were able to replace that. So here is where it gets a little bit even trickier. So I do want to let u equal x plus 1. And I'm going to take du is equal to 1 dx, or you can just put dx, which this takes care of a lot of our substitutions. But we still have this extra x here that's on top. And normally we have something here, an x that we can leave with that, and that can also get substituted there, and we don't have that. So this is where we actually have to do another substitution, and that's really looking at the u. So there's another part to the substitution. So also, if you look at what u is equal to x plus 1. So if I solve for x here, I can say that u minus 1 is equal to x. That is a true statement. So this is going to be a third substitution. If I just see an x, I can replace it with a u minus 1. So I have 3 different substitutions I need to do here. So my new problem is going to be a u minus 1 on top, a u to the, I'm going to put to the 1/2 power instead of the square root, and du. So I can solve this. I do want to split it up first. So if I split this up, it's going to be the integral of u over u to the 1/2 minus 1 over u to the 1/2. And if I simplify that, that's u to the 1/2, because 1 minus 1/2 is 1/2, minus u to the negative 1/2, because it was on the bottom. Again, this is du. And if I integrate, then this is going to be u to the 3/2 over 3/2 minus u to the 1/2 over 1/2 plus c. And then again, when we're dividing by fractions, you can bring them up, but you have to take the reciprocal. So instead of dividing by 3 over 2, you're multiplying by 2 over 3. Oops. U to the 1/2 plus c. And then our last step will be to substitute back in. So let me go to a different slide. And that'll be our final answer.